Hello there. I'd like to welcome you to the Chapter 16 Study Guide, also called the Chapter 16 Review. This chapter deals with the ocean floor. So 20 or so questions, and here we go with question number 1. So same picture from the first slide. And here you are, you're working for the organization that's working out there in the ocean, and you have just thrown something overboard. Are you trying to catch lobster? Well, no, not really. You're trying to gauge the depth of the water. So what is the B word to describe the depth of water? Okay, this is bathymetry, and what you've thrown overboard is a weighted line. Okay, so some kind of big weight on the end of it. So were you doing this back in 1896 or perhaps in the year 1966? Okay, the most likely answer is back in the past, in the 1800s, because this is how they gauged the depth to the ocean floor. So question number 2, we have a nice picture for your consideration, and there's several questions going along with this picture. What device is actually used in this picture? And the name of this device is an ES, or an echo sounder, also called by a single S word that should be more familiar to you. And this is sonar. Okay, what is the purpose of using sonar? Why did they use this device? Well, the short answer is that they used it to determine not only the depth to the ocean floor, but also what the topography of the ocean floor looked like. Okay, so how did sonar actually work? And here are some choices. Does it incorporate or use heat? Does it use wave energy, or does it use sound? And the answer is it uses sound. So here is to be or not to be. It looks like somebody's trying to be funny. So here is a follow-up question to the second question. So which does, between the two choices in the picture, which one does the Navy use to locate lost mines? And that is a side scan or towfish. Okay, here is 2C. This is a picture of the ocean floor. Okay, was this likely mapped using sonar? Could it have been mapped using sonar? And the answer is yes. Could it possibly have been mapped using VLBI technology? And the answer is yes, because that's satellite technology. In fact, that's more likely of the two. So here finally is question number 3. We're going to go over the 3 provinces of the ocean floor, starting with the first one, which is a CM. This is continental margins. Number 2 is deep something something. Okay, this is deep ocean basins. And the third one is mid something something. These are mid-ocean ridges. So question number 4. So how many continental margin types, how many types of continental margins are there? That at least we talked about in class, but I think that's the only ones. And the answer is there is 2 types. And what are they? The first one is active, and the second one is passive types of continental margins. So here is 4 factorial. So this is a picture that I grabbed off of Google Earth. And this is off the coast of Virginia, so the east coast of America. So which type is this? Is this a passive or active continental margin? Okay, this is a passive continental margin. And I know that because it has a very broad, wide continental shelf. Okay, here's 4 factorial, 3 factorial, same picture, but now I'm labeling it with some letters. Here is the M, here is an N, there is an O, and there is a P. So here comes your questions. Which one is a continental shelf? Okay, that is M. Which one is a continental rise? Oh, you thought I would take them in turn, didn't you? Continental rise is O. Which one is a continental slope? Is N, as in Nancy. And what is P? Okay, at least in the picture, P is a deep ocean basin where you might find a sunken ship or 2. Okay, finally question number 5. I have a map of the world with A and B labeled on it. So which continental margin is active or passive? Between A and B, which one is active and which one is passive? Okay, so A is passive and B is active. Okay, so some new letters now. I have G and H. Okay, which one is G? Okay, G is also passive, and what about H? Oh, H is also passive. Okay, the reason why is because this is a mid-ocean ridge, so the two plates are moving away from one another, so that makes G and H both passive. Okay, here is 3 times 2. So is there a trench located where I have the line? The answer is yes and no. Okay, there's not really a trench near the coast of North America, but of course along South America there is. Is this an active or passive continental margin? Okay, that is all active. Here's question number 7, and this Google Earth shot is off the coast of somewhere in the world, which I will indicate here in a second. Is this an active or passive continental margin? Okay, this is active. It's off South America. Okay, so off of South America I have something there, which is indicated by teeth. It's called some type of zone. This is subduction zone because I have the T, which is a trench. Okay, question number 8 out of 20. This is a side view of the ocean floor. And of course this picture is not to scale. That is the assumption here. So is this a passive or active? Okay, it is passive. So your job, I'm labeling all sorts of stuff with letters, and your job is to name all the different parts. Okay, A is continental shelf, B is continental slope, C is continental rise, D is deep ocean basin, and E is a mid-ocean ridge. So here is a picture from chapter 15 from the plate tectonics chapter. Active or passive? Okay, this is an active continental margin because I have the location or the presence of this, which is a trench. Okay, does this have a continental shelf? The answer is yes. Is there a continental slope? The answer is yes, because there is a wall that scuba divers will go over. Is there a continental rise? The answer is no, because it's a trench there. So in question number 10, I'm only drawing part of this because I really don't have time to draw these little round circles all the way through the beds. So what bedding type is shown here where I have big rocks at the bottom of each layer and it finds upward to smaller stuff? Okay, these are graded beds. And if you have graded beds, that's evidence of a TF. What is TF? Okay, this is turbidity flow. Would you find this along an active or passive continental margin? Okay, that would be an active continental margin. But passive continental margins can also have turbidity flows too. Okay, this Google Earth image is taken in the middle of the ocean. And that is an atoll there, which I probably talked about in class. So welcome to the deep marine environment, somewhere in the middle of the Pacific. What is the deepest part of the ocean called where it is very, very flat? Okay, this is a deep ocean basin. Specifically, it's called an AP, or an abyssal plain. So these little underwater things that are sticking up, not above the water, but they're sticking up above the seafloor, these are called by an S word. Okay, these are underwater volcanoes, so they're called seamounts. So here we are in the middle of the Atlantic Ocean, and I have a big crack, I guess, in the Earth's crust. And along this crack, the two plates are pulling apart, just like I'm indicating, with some of them pulling, kind of slipping past one another. So first things first, what type of continental margin is shown here? Okay, this is a divergent plate boundary. Specifically, it's a mid-ocean ridge. Okay, and what do you call these different types of structures here that are sliding past one another? Okay, these are transform faults. And by the way, this is question 4 plus 8. So here we are now with lucky number 13. And a picture for your consideration, and here we go. Is an active or passive continental margin shown in this picture? Okay, that is a passive continental margin because you have the presence of a continental shelf, then a continental slope, and then it merges into the rise, and then you see where it says deep marine. That's the abyssal plain. Okay, what does the word pelagic mean? And it's okay if you're screaming at this point if you don't know. Okay, pelagic is extremely fine-grained, and you're going to find that type of sediment sitting on the abyssal plains. So here underwater we have a nice lovely seamount, which it looks like the top of it has been cut off. So that goes by a G word. So that's a goyot. Question number 16, I take you now to the mid-ocean ridge. This is in the middle of the Atlantic Ocean, among other places in the world. And the first question here is, why is the mid-ocean ridge elevated? What makes it a basic, huge underwater mountain range? And the big answer for that really is that you have hot magma that's coming up into the crack, and of course it's hot, so the rock is swollen. And what percentage of the Earth's crust does the mid-ocean ridge comprise? Percentage of the Earth's surface. The answer is 20%. Okay, now with question number 17, these are the different layers of the ocean floor. So what is that layer right there? These are unconsolidated sediments. Underneath them we have pillow basalts. Underneath we have a complex which are called sheet dikes. And then we have the intrusive mafic igneous rock that starts with a G. And that finally is gabbro. This whole suite of 4 layers is known by an O word, and that is an ophiolite. So question number 18, we're nearing the end of our chapter 16 review. Where are you likely to find these structures in the world? Okay, they're going to be found along the mid-ocean ridge. And what are these things called? Okay, these are known as black smokers. And what form of metamorphism do they represent? And your choices are contact, regional, or hydrothermal. Okay, this involves hot water, so cold water seeps into the cracks and then it gets hot. So this is hydrothermal metamorphism. Okay, question number 19. Your job is to find a rift in the world. Good luck. Okay, just kidding, I'm going to give you some choices. Is there a major rift in this location? What about here bisecting Australia? What about in the middle of the Asian plate or Eurasian plate? What about here in East Africa? Is there a rift? Okay, the answer is yes. It's called the East African Rift. Okay, so the next question. So the East African Rift is doing what is indicated in the picture. And what is that type of plate boundary? Okay, that is a divergent plate boundary, specifically called a rift because it's on the land. So now we're going to conclude by having a nice lively discussion about basalt. So if you have nice hot flowing basalt, as it's cooling, it's going to form one of 2 types of lava that you find in Hawaii. And this type of lava is called A'a and Pahoehoe. Okay, so let's consider the next one. If the basaltic lava is not moving, if it's stagnant and not flowing but cooling, it's going to shrink to form 6-sided structures which are called, inside of a volcano, these are known as columnar joints. And really the big reason why I'm going over all this stuff with this slide is for this one right here. If basaltic lava cools underwater, what type of structures are formed? And these are called pillow basalts or pillow lavas. Okay, this is 20 infinity, so I guess I don't want to give up question number 20. So here we have a subducting oceanic plate on the left, and it's diving underneath the continental crust, which is depicted on the right, and I have 3 letters on top of that continental crust. So the question in this picture is, which letter between A, B, and C, which letter represents the approximate location of volcanoes on land? Would that be A, B, or C? Okay, more likely A, because it looks like this subducting plate is subducting very steeply. And what type of volcanoes are you going to find on the land? And those are composite cones or stratovolcanoes. Okay, this is 20 infinity infinity. This is a very last slide. Felsic and mafic. This is an easy one. Can you name a very common felsic igneous rock? Phaneritic, intrusive, lots of quartz. Okay, that starts with a G. And the B one is a mafic one, which you can find all over Hawaii. And with that, it concludes our Chapter 16 study guide.